What is this loading? And it's already going slow. I thought in the last days it's been a bit better, but it's still. So let's visit the Twitter world and tweet about something really important, which is that we're going to talk about quantum path selection today. So this is Twitch. Not to be exactly. So it's like, I don't know, like do people still like, I hate it when I see a lot of people with just a lot of hashtags all over the place, like these stuff here. Like it's just obviously bullshit. But nevertheless, I keep using quantum computing as a hashtag. I don't know if that has any effect or impact on visibility. Or even like the opposite, right? It might just be like when people see you using hashtags, they're like, oh, that's just like, it's not, this tweet is not honest or something. Quantum code, we're talking path selection. Yeah, let's tweet this. Cool, there we go. Cool, so what are we doing? Now, I haven't fully finished the measurement part, so I have finished it, but it's not yet working completely, as you can see. Namely, it does not work well with the factoring as of yet. It just, so the way this currently works is, and at some point I'll just have to clean up and just move away from just having a prototype. And so the way this works is if I have something like that, which is just a Bell state, right? I can call like I can do like measure, and I can pick like give it just a list of qubits that I want to measure, and then what it's going to do is it's going to just measure them. Now in this particular case, there's nothing else than like the qubits are flagged, with the M, which basically says, this thing shouldn't be, you can't factor them because they are not like, it's not a quantum state. So that's essentially what it means. It means that you're not like, you can't, it's now sort of a classical, it's in a classical state. Like Quirk does a bit, Quirk allows you to play with some quantum gates afterwards, like as long as they don't mix stuff like the Hadamard gate. So for example, if I have a Hadamard and I measure it, like you can still use, or the other way around, like if you can still use the X gate, you can still use the Y gate, and it will even calculate the state vector, assuming measurement deferred, right? Because essentially that's the same, right? So I'm not so sure about these. Quirk, it's easy to implement something like this with Quirk because you have control over the gates, and you can decide what gates you want to work. You want them. I mean, I don't know how Quirk does it, but in my case, like I just prefer, because it's a bit different, right? Like you're working with the system, and so you might have like the way it's not you're specifying shots or anything. You're just saying I want to measure this qubit, and so now this qubit is sort of really in a mixed state. We don't know if it's this or if it's this, right? So you can't simplify. You can't just simplify the hypergraph. But path selection is another beast. It's complicated. I think it's going to be a bit more complicated to handle. So yeah, so the measurement is kind of done, but I'm currently working on just to, basically make sure that the factor qubits implementation accounts for these. And wait a second. Oh, measure qubits. Oh yeah, no, that's okay. But there's something wrong here. Measure qubits. Where's measured qubits being passed? It's not being passed anywhere. So how am I? Oh, sorry. Of course, it's not being passed because it's being read out of this. Anyway, whatever. I don't want to get into this because I don't have so much time today. But what I mean is that it's, it peaks what's measured, and if it's measured, then it does not merge. That's currently my approach, and then I guess I'll have to also adapt um, there's a bunch of things to do still. Revise preconditions, blah blah blah. But this is the boring stuff. I'll do this sort of on the side, maybe. I don't know. If I get some more time for streaming this week, I might do this on a stream as well. You might want to go and make sure that the apply gate function kind of considers this also, to do check if measured, right? Stuff like these. The same with 2 qubits, right? So if things are measured, you should be able to apply like at least certain operations to them, to these qubits. But let's talk about pos selection. So for pos selection, pos selection, I want to do it the way Quirk does it. I really like it. So pos select, this should be camel cased. To be honest, it's like, I don't know if to implement it with sort of qubits, like you give it a bunch of qubits or just kind of allow for 1 qubit first. I think that's what makes most sense, because the way this is supposed to work, right, is, so I have these. Here, let's walk through some examples, right? So we have the state, and then if I pos select on 1, right, it essentially doesn't change anything. And the way pos selection works in Quirk is, and I specifically don't want to implement these as any sort of like matrix multiplication or whatnot, which I know you probably can, but I really want to work natively with a hypergraph. So that's cool. Like, yeah, pos selection, it's like what this is going to try, what this gate is doing is leaving the system at the end as it would be if you would measure and pos select this qubit for the states that are equivalent to 1. So that's easy. If it's a 0, so here we've got like a sort of exception cases, right, where while Quirk is telling you if you pos select for 0, then you'll just end up with nothing, right, because there's no such state. If the qubit is in the plus state, then that will omit, that will basically omit these. So essentially what this is doing, right, is it's literally kind of collapsing, or it's literally putting this qubit, forcing this qubit to be in this state. Now the trick part here is going to be what happens when we've got branches. Because my guess is, like, I don't care. I think I'm not going to try to calculate how much you keep, although that might be useful. Let me just add as a note to do calculate how much we're omitting, like Quirk does. Because that's kind of basically easy. You've got a qubit, right? It's let's work with an example here. I'm just going to remove these. This is still a good example because I'm still working on this. But let's just add another cell on the top, and it's just like, so if I have a qubit system with a qubit, I apply like whatever gate, right? What am I doing here? Say, yeah, whatever these. I draw the system, so that's a very simple system. So if I were to do system post select Q0 and give it I have to give it a state, right? And I think I've got I've got this defined in here, and I should probably have I think I should have that already. Plus state minus state, which is basically which is basically the plus state is this, the minus state is these, right? And I should have, oh, we can do later the I state and all that stuff. Initial state, excited state, plus state. I should call it 0 state and 1 state, but whatever. Def post select. What am I looking at? Post. Excited, no, initial state. So this should just leave the state into like a 0, 1. Like it should just transform this state into, like it's not even splitting or anything. Like at that point, you're like your world just becomes the world after post selection, so to say. So you have, so you kind of have like the stuff that is left. It just disappears. So it's like you're not, like your system is still, it's just 100% in this state, right? The same with these. Now, if you post select them plus, then it just stays as plus, right? So essentially, it seems like the post selection, just like for the no branching scenario, is just replace. It's almost like you just replace that qubit for that state. Now, that's not, the replacement is not a good idea because, well, that's like, that is illegal. Like if I do these, like these just can't happen. So how would I do that? So I'm given initial state. I'm given an initial state, and like it doesn't feel like clean enough to just kind of, go in with the naive, and it's like if there's no overlap, then how do I even want this to work? Like, do I want the hypergraph to be empty? Do I want the post selection function to actually spit out an error? Do I want it to spit out an error? That's a good question. It's not an error. I mean, it's not an error. It's just like you're emitting absolutely everything. So this is just literally, yeah. I mean, so quirks is not a number. That is some sort of error. So I think I'll just go with an error. But then I need to understand if that only happens when these two, when the state and the post selection state are like totally totally not orthogonal, but like totally opposites, right? Yeah, totally orthogonal, of course. Totally orthogonal. Like if I have a 3-qubit system and I put myself into the 111 state, and I post select for and anything that is not 111 will just give me not a number, right? So it's going to be orthogonal. So I do have to, it's like I almost kind of like, here probably it's the dot product what you have to do, right? Because the dot product tells you whether the two complex numbers are orthogonal or not. Like if I'll call it p state. If p state orthogonal with qubit state, then spit out error. Now the problem is what if we have what if we have different branches? Like, so what if we have, because then it's not an error, right? Then it's just you're killing the branch. You're literally killing the branch. If you have, let's put it, okay, so let's do a, probably the simplest case would be a Bell state, right? So you have this Bell state. So now we have the so you have let's build it. Let's build that quick, real quick. Real quick. Apply to cubic gate. If I now pos, what do I expect? If I pos select qubit 0 on 0, I expect this branch to disappear. Sorry, this branch to disappear. That's the 0, 0 branch, right? If I pos select, not on 0, sorry, on this one disappears because it's in 1. It's in the state 1. So if I pos select these on 0, then I know that I have like a that I know that I'm in that state. I think from a design perspective, I'll follow the same approach, which is I'm not going to automatically simplify stuff. I'm just going to kill branches. So effectively, okay, so effectively, actually, that's the behavior, right? So I think you iterate over each branch where the qubit is in, and if it's in no branch, then it's just the one that we have in the system, and then check if the states are orthogonal. Okay, so now that's interesting. So what if I postulate for the plus state here? Because then if I do that, it will literally turn this into the plus state, and will it? If I if I'm on the 0 and I select for the plus, I have a plus. If I am on a 1 and I select on the plus, then I'm also on the plus state because it's just, yeah. Because I think that I like the fact that I'm separating the factorization from the whole thing, because I can literally leave the hypergraph in whatever state I want, and it's the user's responsibility to kind of compact that with a factor, with a call to factorization, right? So I kind of hated that this tree, like I really don't know if there's people watching. If I see users in chat, I see there's a user. Hi, lemon juices 12. Thanks for watching. But it doesn't pop up in my chat actually. So apologies if I just don't welcome anyone. I got to get better at this all Twitch thing and add some nice stuff in the page as well. But I like the way this ended up being designed. Or maybe if I take a look at the phone, because essentially I can leave. So now I have like the mobile live dashboard, and I can check. Okay, I can see the chat. I can see that I have one viewer. Okay, but it does not seem to reconnect to the chat properly. Because I'm looking at the OBS chat, which is pretty neat, and it's nice that you can have a chat in here. Yeah. Anyway, and so it would leave this in the plus state, and then we can merge things. Then you can actually factor things out. and it would actually leave the whole system in the plus plus state, would it? Let's try. So so this is the bell state. If I pause select this in a plus, yeah, that works. So that might be simpler than I ever expected, literally. So if I go, and there's no measurement involved, no shit like this. It's just, come on. Okay, so what I should do is I should just say, first of all, I need to get qubit node IDs in Edge. The qubit and the no qubit edge IDs. That's what I wanna go for. Dev post selection. So I want to get the edge IDs. The edge IDs for qubit. So now I know the edges in which this qubit is in, because everything else just stays the same. And now I just basically say for edge ID in, for EID in edge IDs. So I'll just iterate over each edge, right? I mean, assuming that, of course, if edge IDs, is this a non-value or an empty array? Probably is an empty array. Yeah, it's an empty array. So if length of edge IDs is actually bigger than 0, then we do the thing, right? If not, we do something else. Else, I mean, that's the else. Yeah, okay, so let me just get rid of this. So what I do is, so numpy array dot product. I think it's just dot. So for edge ID. So now I'm in each edge, and then I basically that's stupid. Actually, I think there's a faster way to do that. Get qubit node IDs. I just don't care in what edge are they. I just want to get the nodes. To be honest, I just want to get the nodes. So node IDs is equals self qubit node IDs qubit, and so what I do is for node ID and node IDs, and now I need to check, right? So I need to get the node, self nodes, node ID, cool. And now I need to check dot product. Dot product, I guess it's dot. So it's basically, so if, I can't believe that's that easy to implement, but if np dot, and we basically take the node state, which is, yeah, node state, and the p state, if this is different than 0, then we just replace the state for this state, right? That that's like the problem is that we might end up with a sort of an in-between step where this is kind of illegal, in the sense that the state vector won't make sense anymore. Like should I change the should I change the probabilities of the should I change the complex, like the stuff that I already have at the edge level? I don't know. We'll see. Um, cool. And if not, else, I'll just kill. I just just get rid of. I just get rid of the edge. Question is, do I really delete, like this is going to be a mess, because if I delete the edge, then I'm 100% sure that these probabilities won't just make sense anymore. So, but I don't know how this is gonna. I should probably update those at this level, the edge complex numbers. But I don't know how. Let's see. So else delete, no, delete edge. Like, do I have to delete? So delete edge, I think, assumes that the edge is empty. Hmm. Get node ID in edge. So I just need to not delete, but delete node and delete edge. So dev pos select. So what I need to know, what I need to do is basically, okay, delete edge IDs. So I should just append that, because there can be multiple edges that you might need to get rid of, right? Remember, there's going to be multiple edges in there. So what I need to do is delete edge IDs, append, you know, this stuff in here. Okay, and if the edge ID, edge UID, if the edge UID is null, I guess then is where things get interesting, right? So then it's where it's like, what do I do? Like, I think I should just leave the hypergraph empty, to be honest. Anyway, I append this stuff in there. So there's going to be some nonce in here. If so, in this case, I just delete the nodes from the nodes list, and that's it. Cool. So after I'm done with the whole process of going through these and changing the states or adding the edges to be deleted, then I go for delete edge. I'm so shitty at picking variable names that this prototype is just because I had just put the excuse on me that I just can have whatever I want. Like, it's just, I'm prototyping and I'm so bad at, like, it's going to be a hell of a work to actually put that into proper code in a library, but whatever. So for these IDs in here, all we need to do is, for node in self, well, first of all, if is none, then it's sort of its own case. Else I go, so edges, I get the edge and I get the node UIDs in there. And so for each of these node UIDs, what I do is self-delete node, and I give it the n. And at the end, when I'm done, I just go and say self-delete edge. I think that should work. And in this case, I just go and say delete self-delete oh crap, I don't know what node this is in. So I'm getting, oh, I think I can just delete it here. Maybe. I can delete it already here because I know the node. So I can say else, and I can say if, you know, the thing is none, just delete it here. Just delete it on the spot. Else add it to the edges to be deleted later. So if you know, if this is none, this means it's in no edge, so it's sort of in the at the system level, it's not entangled, and would not then delete the node. And otherwise append the edge IDs, and then just go through the edge IDs to delete the nodes and delete the edge. I hope that works. I really hope that works. How is this mobile thing going here? Let's see. It doesn't seem to work, to be honest. How can I see? So I see in the chat here that there's like 1, 2, 3, 4, 5 people watching. Thanks. Hi, everyone. I hope you're still watching. This is just real data, not fake data, but because the app tells me something else. Anyway. And I promise I'll be doing a bit of an explainer on these soon as I get a bit more advanced. I mean, I think I'm done. Like once post selection is done, once measurement is, the little to-dos that are left for measurement are done. To be honest, factor, expand, and expand qubits are just utilities that allow you to manage, that will allow you to manage the graph a bit better. I mean, I like the expand qubits because we have the factor, but we don't have the expansion. So that could be an interesting one to work on. But then I think we're pretty much done after that. Anyway, let's test this stuff. So because I'm sure this is going to be buggy, at least from because I'm not touching any of the amplitudes and any of the complex numbers that I have, and I have a bad feeling about these. Let's do a first simple test, right? So we have, let's do just a 1 qubit system. And we apply just, the X gate, and let's just first check what we have. So we have a really simple system with the excited state, and I'm going to pause select for the excited state. And it breaks. Pause select. No pause select. How? Of course it has. Post select. There you go. Oh, well, what about I just run the cell? Unexpected indentation error. Where's the indentation error? Is it here or what? Oh, what is this? I think I accidentally squeezed an F. Okay, so we have... Okay, seems like it worked. What if I pause select on the initial state? Boom. I'm not deleting this node. I'm deleting node ID. Exactly. Cool. We have an empty. we have an empty. Yeah, we have an empty graph. What about I just fix draw to account for these? So, well, I'll just say if literally like if length of self nodes is 0, then print something like empty. I don't know if empty state is the right word. It's just that there's nothing. Nothing exists in there, basically. It's just empty state. I don't know if that's the right thing, but yeah, we'll get an empty state. Or maybe not an empty state, but like let's put let's say it's an empty hypergraph. Initial empty hypergraph. Cool. What if I select for the plus state? Wow, works. Minus state. Yeah. Oh, yeah. That's correct. The minus state. So plus state. So and even if we don't do these, the plus state is the plus state, the minus state is the minus state. I think that all works well. Now, so this is okay. This works. I wonder what's the I wonder what's the sort of the meaning of these in terms of like if I'm in the plus state and I pos select for these, like why does this even work? But that's for another. That's just like why like I'm just gonna be measuring zeros, right? So how can I pos select for how can I pos select for a state? Oh, okay, because pos select for plus, it probably means apply Harmon gate and apply a measurement, right? So you're measuring across. Okay, so what this means is measure across these bases and then do pos selection of that particular computational base state for that basis, right? So pos selection of plus would mean apply Hadamard gate. So that would be the equivalent of saying apply Hadamard gate and pos select for 0. Well, and then apply another Hadamard. Yeah. That's the reason. Let's play with more complicated stuff now. Let me add. So first we're having a let's have a bell state. So at the bell state, let's print the let's print before pos selection. Let's do print of the system states vector. State vector. There you go. So this is, you know, so they all match. And now what if I pos select for Q0 being on the initial state? What's gonna happen? What? Yeah. As I thought, it leaves us in an invalid state because it's done the right thing. It deleted the edge, but then oh, maybe it shouldn't delete the edge because if it deletes the edge, wait a second, why did it delete the qubit? Why did it delete the qubit? No, what did it do? Wait. Something's wrong here. Oh, what am I doing? Yeah, that was weird. Like what? Actually, wait a second, because it was not a bell state, obviously. So yeah, but it deleted the qubit. It should delete the qubit, should it? Actually, what should it do? So if I have, oh yeah, it does actually. Okay, so it actually, yeah, it actually kills the whole system. Yeah, it should delete the whole branch. I should treat the system as a branch. Actually, that was a good test. So actually, what am I doing? So what this should do is it shouldn't just delete the node. It just should kill all the nodes that have. Yeah. So if we find, yeah, it should invalidate the whole thing, but it shouldn't do it here. So delete not entangled. False. So delete not entangled false. And so what this does is it just sets it to true, and then because I wanna, it needs to just still go through all the rest of the stuff, and then here what it does is um, so I get the qubits non-entangled self get qubit node IDs um, in edge, and it's qubit and it's the non-edge, and then for node in non and non-entangled, basically self delete node, and so it deletes the whole thing. Like if we catch one, it just I think I just patched it, but I think there's a better way to simplify this. But I think that should do the trick. So if I pos select a system like that, get qubit. What is the non-entangled? Obviously, I'm the king of the typos. Non-entangled. What? No, no. What am I doing? This is just crap. I'm just, no. Self nodes, and then Eve self nodes and edge UID is none. Then delete, then just delete all of them. So it treats the non-entangled as a branch. Actually, if it's got actually, what if you have these and then like, that's not, like not entangled, and I pos select on 0. Yeah, it just kills the whole thing. It actually should kill the whole damn thing. It just yeah, because not entangled is it doesn't leave the other ones because these should be just factored in. The fact it's not entangled doesn't mean it's only within branches that. Okay, so it should actually delete everything. Just delete all nodes. Delete system. I mean, that probably um, I can just set the whole thing to an to an empty array, to be honest. Uh, if delete system, if delete system, like delete the system. Mm, well, that's something I should probably do at the end, just in case, right? Come on. I'm gonna copy that, then I take reindent this stuff, and there you go. So delete whatever branches, but at the end, if it just delete the system, just delete the system. I think for the sake of um, I think for the sake of consistency, although probably it's irrelevant, I should also do that. So I just leave the system really empty. No, that's wrong. Pause select. So delete system is true. If delete system, so if the node self node self edges. Destroy. This is how it doesn't even get there. Why? That is wrong. Wait a second. Oh, I spotted it's a bug in this. That is definitely. Oh, okay. It's not a bug, but it's the only edge. It's really definitely not a bug. It's a valid system. It's just that it's not a system. It just thinks it's an edge. Uh, I have to. Uh, I think I know where the problem is. This is here. This is this part here. I need to do. But the factoring should do that. Come on. I think the factoring should do that, not the create edges. Like this is just goes. So this is the part of the code that takes care of recreating after factorizing stuff. Sorry, after applying a 2-qubit gate and factorizing stuff. But I haven't factorized anything. I've applied a 2-qubit gate. So if I apply a 2-qubit gate, but I should yeah, okay, that is a bit of an edge case. Like, should I? Yeah, in theory, I should just say factor qubits, just because I have to factor them out. But that should account for it. I mean, it should delete the whole branch because there's a branch. You know, that should actually, because this is a valid state. Come on, it's just that the pause select, like, okay, so it goes there and it's delete edge IDs. So actually they should print the edge IDs to delete. And why aren't they deleted? Ah, edge 7. But why is edge 7 not deleted then? What am I doing here? So for each delete edge IDs, go through the node UIDs and delete all the nodes within this edge. Why isn't the node being deleted? Print deleting. Why is it no? Oh, Jesus. Maybe there's a bug in the edge creation or something. Because why isn't it there? I think, okay, that's definitely a bug. So, well, node 4 should be in edge 2 as well, right? Why isn't it there? It's a bug in these. I think it's back in these function. For some reason, it's not added. Okay, I'll add a node in here. Back for a circuit like X and CX. Yeah, seems like a node is not added to the edge properly. I gotta fix that. That's probably what's happening. Okay, but that's not what I wanted to do. I wanted to do these. So I wanted to have these and say, okay, now I have, you know, this stage, and now I wanna measure, I want to pos select Q0 on the initial state, and so that leaves that should just leave me with this branch. Okay. Oh, what's going on here? The state vector. Oh, something's broken with the state vector. Oh, there's a back in the apply to qubit gate for everything. Jesus Christ. It does not. It looks like qubit 1. Come on. It looks like qubit 1 is not being added. When am I adding stuff? Garbage collection. So I'm doing it here. I'm adding P, I'm creating P, I'm creating Q, and I'm adding them all to the edge. So why isn't that the case? This should work. P and Q, P and Q. Right? Okay, I gotta figure out why this doesn't work. It seems like for some reason that is not there. But that's rather a back of, you know, of the 2-qubit application. It seems like that should work. Because I'm getting delete edge IDs, and so I'm getting edges, node UIDs. This is really, you know, this is really, so an edge, a hyper edge has node UIDs. Yeah. Okay, I think that's a bug somewhere else, because it should, what it should do should delete the whole edge. So it should basically go through the deleted edges, and then for any node UIDs, delete the node, and it doesn't even print that, so, and then delete the edge. Which it doesn't, because it hasn't emptied the edge. So that's the problem, is it doesn't seem like the add to edges function kind of works. Okay, but I think we almost got it done. I just need to then make sure that I can test and that things do work as I expected, in terms of that the state vectors are consistent across, like, you know, before and after pos selecting. because I think essentially post selection. Well, the thing is, it does change, right? Like it just I just want to make sure that I get that it computes correctly. I want to make sure it computes correctly. You might end up with a funny hypergraph, even like this one, but it just should compute correctly. I think I have to keep an eye on sort of these intermediate representations of hypergraphs where like, think because I'm putting the responsibility to the user to kind of call factor qubits to kind of clean up the hypergraph and have it like as factored as possible. And that can be, I hope that doesn't lead to some sort of, weird in between representations. Anyway, I think that was a good session. And I feel like I'm kind of almost done with all these. So, good stuff. Goodbye, and thanks for watching. We'll put that into YouTube as well right away.